Good morning, my YouTube viewers. Crystal here. I wanted to put together another video for you. I've been working on one all weekend long making videos because I've been taking old programs that I had written when I didn't know as much as I know now, which I certainly don't know a lot now. And I've been re-preparing them in a new format to make them easier to read, more structured, in a standard format, so everybody can look at my programs and they can say, okay, well, they've been written in a standard format. And the title of this video is going to be, what is the best classifier to use? And what I've done is I've used Analytics Vidhaya question on their hackathon, and it was an HR question with regard to promotions, and it's on my GitHub account, so you can go into my GitHub account and find this program and follow along with me if you want to. So what we'll do is we'll go over the problem statement. Your client is a large MNC and they have 9 broad verticals across the organization. One of the problems your client is facing is around identifying the right people for promotion, only for manager position and below, and prepare him in time. Currently, the process they are following is they first identify a set of employees based on recommendations, past performance. Selected employees go through the separate training and evaluation program for each vertical. These programs are based on the required skill of each vertical. At the end of the program, based on various factors such as training, performance, KPI competition, only employees with KPIs completed greater than 60% are considered, etc. Employee gets promotion. For above-mentioned process, the final promotions are only announced after the evaluation, and this leads to delay and transition to their new roles. Hence, company needs your help in identifying the eligible candidate at a particular checkpoint so they can expedite the entire promotion cycle. They have provided multiple attributes around employees' past and current performance, along with demographics. Now, the task is to predict whether a potential promotee at checkpoint in the test set will be promoted or not after the evaluation process. So the first thing we did was we loaded up our libraries, the main libraries that we would need, which would be Pandas, NumPy, Matplotlib, and Seaborn. And I notice here I got Matplotlib twice because that was one of my first programs that I did, but it doesn't matter. The second thing we did was we loaded up the files. The files are in my GitHub account, so you're more than welcome to use the files that I've loaded onto my GitHub repository. If you don't want to use those, you can go into the Analytics Vidhaya website and download them. It's entirely up to you what you want to do, but I've got my files loaded in the repository that you're more than welcome to use. So we look at our training file, and you see we've got lots of information on the train file. We've got lots of object data that's going to have to be converted to numeric data, because that's what the computer wants to see, is numeric data. We've got a description of the train file, and we've got the test file. The test file is the same as format as the train file, except it doesn't have an is promoted column. So now what we do is we check for any null values, and we've got null values in education and previous year training. And what we're going to do with these null values is we're going to impute them. So just with one line of code for the train file and the test file, we're going to replace all the null values in the train file and the test file with the mode. And so the mode is the most commonly used number, or the most commonly used values. And so you could use median if it was a numeric value, but since these are not numeric values, you cannot use median. We check for null values again, and after we've done that, we have no null values. So now we do is we have to label and code our objects with the label encoder command. So all of the object columns are converted to numeric columns, and so basically every category is given a number. So the computer can use that as the basis to make its calculations, because the computer has to have numbers to do its work. Now what we do is we graphically represent our target data, and as you can see, we have a imbalance. We have a class imbalance, so we have more zeros than ones, so that means more people are not going to be promoted than they are promoted. And so we can count that, put that on the counter, and you can see we had 50,140 were not promoted and 4668 were promoted. So we got a graphical representation of this file, and you can see how the different independent variables relate to the dependent variable. Now what we do is we define our x, y, and x test values. So y is train is promoted, x is train drop employee ID and is promoted, axis equals 1, and x test equals test drop employee ID, axis equals 1. So we split our training set into training and testing, and we use train test split for this purpose. And then what we do is we have x train, x val, y train, y val equals train test split, x, y, random state equals 0, test state equals 50, stratify equals y. And I didn't see the test state equals 50, but it should have been test state equals 10%, but that was a mistake. But you know, your test state can be any test that you want it to be, but the more testing data that you have, the more accurate it's going to be. So really what I should have done is I should have done test size equals 10%, stratify equals yes, and then you could have said shuffle equals true, and that would have given you a more accurate, potentially a more accurate prediction, which I think when I finish this, I'll go through and change it. And then what we've done is we set our scalar up. So we fit our scalar on X train, and we transformed it on X train, X val, and X test. We assigned our class weights, and so because we wanted to balance the class weights, and so what we've done is we've done a graphical representation of y val. So even though I sort of did the test data by mistake at 50%, because it's an imbalanced test data, maybe that was the best thing to do, because I had a better chance of selecting the number ones in my test data. So now what we're going to do is we're going to build our model, and what I've done is I've selected 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 classifiers. All of the classifiers except one can be found on the sklearn website. And I could have put more classifiers if I had wanted to, but you can always go to the sklearn class website and find out the rest of the classifiers that I didn't include and include them in the prediction if you want to. So I set all of these classifiers up. We set them up in a model so it would, with a stratified k-fold, and then we would do a cross-validation, and then we set it all up so it would give a score for all of the 11 models. So you can see Random Forest has 67.93%, so that's not very good. And you got all this scaling done over here, which the first time I did this, I didn't have the scaling, but I did a little bit more work. I did a little bit more fine-tuning of my parameters, and I suspect that's where the scaling comes into play. And I think that the last time I did it, maybe I didn't scale it in the first place, and because I didn't scale it in the first place, it never got rescaled. But here it gets rescaled, and so what we have to do is we have to go through all of the rescaling to find out the values of the other models, which is what I'm doing here while I'm talking to you, keeping you actively engaged in the computer, because it took a long time for this to go through. And so that's why, it's because it took such a long time for it to go through. You're not too keen to redo it. But my LRCV, that's logistic regression CV, was only a 71.79%. Linear discriminant analysis was 91.28%. K nearest neighbors was 91.09%. Decision tree was 90.25%. Extra trees was 92.78%. And NB, that's Gossam GB or something, that was 91.18%. SVM was 53.45%, and XGB was 92.79%. HGB, it didn't give you a value at all. I'm not sure exactly why that is, but it didn't give you a value. And MLP gave you a value of 93.09%. So MLP actually gave you a higher value. So in theory, if we were going with the values alone, then we would say, well, MLP gave us a higher accuracy, so we're going to go with MLP. But this particular competition question, it uses something called an F1 score. So we eventually ended up not going with the MLP. We went with the XGB, and I found XGB is normally the best model to use. It's just a really good overall model, and it also is good for class imbalances. It's good for outliers and all sorts of things. And so I found XGB to be a superior model. And then so now what we've done is we've plotted our models, and you can see how the models fit. So RFC is not very high. Linear regression CV isn't very high. SVM is even lower than RFC and linear regression. And the rest of them are up in the 90s. So in theories, you could use any of those. So now what we're going to do is we're going to make our prediction, and we're going to fit it. So we're going to fit it on the X train and Y train, and after it's been tuned, and then we predict on XVal, and then we get a 93.09% accuracy on XVal YVal. We put it on the counter, and 25,813 were 0, and 1591 were 1. And then we put it on the F1 score, and the F1 score is a different type of score. I can see if I can find out if F1 score is there. I'll just look right here. You can get it on your sklearn website, and it's a metric, and compute the F1 score, also known as balanced F score or F measure. The F1 score can be interpreted as a weighted average of the precision and recall, where an F1 score reaches its best value at 1 and worst at 0. The relevant contribution of precision and recall to the F1 score are equal. And then it gives you the formula of the F1 score. And but that's basically what Analytics Vidhya used to grade this competition. So that's why I put it in there. And so we created a confusion matrix so you can see how many zeros you got and how many ones you got. And then again, we plotted this on the displot, and you can see right there, you can see that the class imbalance that we had. So even though I originally I had set it up as 50% as a mistake, but since there was such a big class imbalance, maybe that was the right thing to do. So we found our sample sub. This is what Analytics Vidhya wants to see when you submit your prediction. So then we made our prediction on the X test, and then we sent our output to a data frame, and then now we converted this data frame to a CSV file, and the CSV file is what we actually submitted to Analytics Vidhya. So that completes it for this presentation. And as you can see, I've got all of the different models that you can use. Not all of them. There's more models. You can always go on the sklearn website and find some more models if you want to, find out how they work and put them into the model algorithm and see how they work, see how they come up. But I found XGBoost to be the best. In most instances, XGBoost is the best. So if you like my video, please like, subscribe, and share. If you like the work I do and you want to leave a donation, then I've got my email address down below with my PayPal account. And the reason why is I don't have enough subscribers. So if I want to make any money off of my account, I have to ask for donations. So thank you so much for watching my video, and I look forward